Are you building or maintaining WebRTC systems? Do you want more reliability? What about faster development speed? How about development team leverage? Stick around. I'm going to talk about one way to approach signaling that might give you all three of these. Hi, I'm Cameron Elliott, and I help developers and their managers to bulletproof, scale, and simplify their WebRTC systems for both WebRTC conferencing and broadcasting. Connect or follow me if you'd like to accelerate your results or harden your systems. At my website, you can get my free guide, Top 10 Tips to Accelerate, Decomplexify, and Harden Your WebRTC Systems. Okay, let's jump into it. So you're about to build your own signaling server for WebRTC, or you've already built your own. If you're using an off-the-shelf server and you're constrained to use their particular server signaling protocols, this video might not apply to you. But if you've written your own signaling server, or you're about to go down that road, this video might provide insights that can accelerate development and improve reliability. It's not hard to write a signaling server using Go or Python or Node.js. But I really think it's worth considering off-the-shelf PUBSUB message brokers and servers and protocols such as MQTT for the benefits they can bring. So let's get into it. Reason number one, reliability. Reliability is the first reason to consider MQTT PUBSUB messaging over writing your own raw WebSocket protocol systems. So it's hard to convey the importance of having reliable systems unless you've been there when everything's gone to heck. But I'm going to give it my best shot. Systems fail. They're all going to fail one day. So you really want servers and systems that are going to be as reliable as possible. If you're just building your servers and you have no users today, it might not be your primary concern. But if you can get it for free, you really ought to take advantage of building reliable, fault-tolerant systems. When you get to the point where you've got 2,000 users and your signaling server stops working correctly, if it's not built in a fault-tolerant manner, you're going to have to stop whatever you're doing. And you're going to have to start debugging your system and resolve the issues so things can start working again correctly. And it might be 4 a.m. in the morning, and you've got to wake up, you got to get out of bed, and you got to start debugging. Or you might be at dinner with someone special, and now you got to interrupt your dinner, stop what you're doing, and worry about your signaling system. So if you have a signaling system that doesn't have a single point of failure, it might reduce or even eliminate those instances where things completely stop working and you've got to wake up or interrupt what you're doing and go diagnose your signaling server. So let me talk real quickly about what a single point of failure is. A single point of failure is a component in your system such that if it goes down, your system as a whole is not working or functioning. So if you look at the domain name system, or DNS, it's designed so there's no single point of failure, so that when you type in www.google.com, if one of those two DNS servers go down, it doesn't matter as a whole. Everything is still operating and delivering IP addresses when you search for a hostname. That's the kind of functionality you want in your signaling server. 0 single points of failure. You want it so that one piece of your signaling server goes down, there's 2 backups running that are keeping you going. So you don't have to get out of bed at 4 a.m. or you don't have to interrupt what you're doing when a particular VPS goes down. Now the interesting part is that you don't really want to get distracted with this when you start building your system. You want to think about it really as little as possible, but you want to have the possibility to grow into fault-tolerant, 0 single point of failure system designs. That's the key reason right here to use MQTT. If you start with MQTT, it'll be quite easy and simple in the future for you to grow into a fault-tolerant 3-server cluster that can robustly handle single servers crashing and to continue operating. But you don't need to design it, you don't need to think too much about it other than wanting it as a long-term goal. You just know that if you use MQTT rather than your own off-the-shelf signaling server, that you've got the ability to grow into fault-tolerant clustered signaling operation. So that's the first reason I'd really strongly consider using MQTT over custom signaling protocols. If you choose MQTT, you've got a lot of choices for software that can cluster and implement 0 single point of failure fault tolerance. Reason number 2, development speed. So it's not super hard or complex to write your own signaling server, but there can be quite a few things to think about. So you can use Node or Go or Python for raw WebSockets. But you've really got to start thinking about quite a few different things. How are you going to do your TLS encryption on your WebSockets? Are you going to be serving HTML at the same endpoint? This makes browsers much happier. Do you need an authentication system? Raw WebSockets has no standard authentication system defined, so you kind of got to basically build your own authentication system. If multiple browsers are exchanging WebRTC, SDPs, and ICE candidates at your server, how are they going to find each other? This is not a difficult problem, but it's much more constrained if you use PUBSUB messaging. So there's a number of different managed service providers that provide MQTT over encrypted TLS WebSockets. This allows you to get started really quickly. In fact, MQTT includes authentication built into its standard, which raw WebSockets does not. So if you end up choosing MQTT over TLS WebSockets, you can have that up and running in under an hour from the managed service provider. And you won't even need to start a virtual machine in the cloud. So what's the third reason to consider MQTT? Team leverage. The third reason to consider MQTT over building your own signaling server is team leverage. What happens if you leave to go to another project or another company someday? Or if the team maintaining your WebRTC signaling grows beyond yourself? If you're using off-the-shelf MQTT PUBSUB signaling, then there's great manuals and videos on how PUBSUB over MQTT works. And if you're using a leading message broker, then there's also going to be documentation and videos on how that message broker works and gets installed and is maintained. In fact, from a manager's perspective, it's great because there's probably also developers or consultants who have experience in using the leading message brokers supporting MQTT. If you find this video useful, please hit like and subscribe. At my website, you can get my top 10 tips guide and subscribe to my email newsletter. Here's our bonus tips. Tip number 1, always use MQTT over encrypted TLS WebSockets. This gives you encryption for security reasons. Tip number 2, consider using a managed service provider to get started. This means you can get started with MQTT in minutes rather than hours or days. But when you're ready, if you need, you can deploy your own Docker instances. Tip number 3, RabbitMQ. This is the world's most popular message broker. RabbitMQ, with over 1 billion Docker downloads from Docker Hub, supports MQTT over encrypted WebSockets. This is one messaging server to really keep on your short list if you eventually decide to host your own. Tip number 4. In the comments, we link to our preferred MQTT JavaScript library. We like it because it supports async features and makes it a lot easier to read code you are writing for WebRTC signaling. Are you a developer or manager of developers working with WebRTC? Do you want to build solid, scalable WebRTC systems? If so, please follow the link in the comments below. You can get our free guide, you can ask a question, or you can even suggest an idea for a WebRTC video.